AOPS Volume 1, the basics, number 96. If a set of markers is placed in rows of 4 each, there are 2 markers left over. In rows of 5, there are 3. In rows of 7, there are 5 left over. So find the smallest number which this set should contain. And this is really just a alternate version of the previous question. So as usual, remainders, modular arithmetic, always. So in rows of 4 each, there are 2 left. So let's say the number of markers is x. So x should give a remainder of 2 mod 4. Excuse me. X should remain 3 mod 5. And x should remain 5 mod 7. And we see here that each remainder is 2 off than the divisors. So apply a modular arithmetic property such that if a is congruent to b mod n, then a plus some number such as m must be congruent to b plus m mod n. In this case, our m is going to be 2 because the difference between n and b will be 2. So x plus 2 should be congruent to 4 mod 4, and x plus 2 congruent to 5 mod 5, and x plus 2 congruent to 7 mod 7. And if the number is congruent to a number which is the same thing as divisor, it is sufficient to say that x plus 2 is divisible by 4, 5, and 7. In other words, it's congruent to 0, congruent to 0, congruent to 0, because if it's divisible by some number, it will give a remainder of 0. That is the definition of a divisibility. So to find the smallest number of markers, we just need to find the least common multiple of 4, 5, and 7. Well, since 4, 5, and 7 do not contain any like factors, then we just multiply them up and we'll get the least common multiple. This becomes 140. Hence, x plus 2 is equal to 140. X is equal to 138. So the smallest number of markers that the set could contain is 138 markers. And the reason why, as a review, that x plus 2 is equal to 140 is because x plus 2 is divisible by 4, 5, and 7. And since 140 is divisible by 4, 5, and 7, x plus 2 must likewise be divisible by a number which is divisible by 4, 5, and 7. So x is equal to 138, the solution to our question.